Let's practice subtracting integers and rational numbers together. Keep in mind that when we are subtracting integers or rational numbers, that we can actually turn all subtraction problems into addition problems using a little strategy that I like to call keep and then change and then flip. For all of these practice problems dealing with subtraction, we're going to keep the first value, change all subtraction to addition, and then we're going to write the opposite of the second number. For these first few problems, let's go ahead and use a number line to show how we can subtract each of these following integers. So for number 1, we have 8 minus 5, which is pretty straightforward here, right? But I want you to just get in the mindset of practicing this keep, change, flip so we can get the same answer using another strategy, right? So if we keep the 8, what we're really going to have here is that's going to stay as an 8. For the minus sign, we're going to change it to a plus sign. And then this 5, we're going to do the opposite of 5, which is going to be a negative 5, right? So now this is an addition problem, but it's going to get us the same answer. So how do we show using a number line to get this answer here? So let's go ahead and make a number line. Let's go from negative infinity to positive infinity. And let's see, we're starting off with a number 8 here, and then we're going to be moving to the left because this is a negative 5. So let's go ahead and put 8 all the way over here to the right. And then let's put maybe a 7, and then a 6, a 5, a 4, a 3, 2, 1. Looks like I'm running out of space at 0, so I'll just stop over there. So starting with this first number of 8, we're going to go ahead and plot a point on the number line there. And we're adding a negative 5, which means we're moving to the left as opposed to the right if we had a positive 5. So let's move 1, 2, 3, 4, and 5. So we end up at positive 3. So 8 plus negative 5, that's equal to positive 3. Hopefully that makes sense just because 8 minus 5 is also equal to 3, but I just want to show you that this does work. For number 2, we have 8 take away negative 5. This one's a little bit more confusing, right? So I think KCF makes a little bit more sense to employ here. So we have K, C, and F, okay? So if we keep the first 8, that's going to stay the same. If we change the subtraction to addition, and then we go ahead and flip the negative 5 and write the opposite of positive 5, this is really the same thing as 8 plus 5. So 8 plus 5 is a pretty straightforward problem to do, I think. But let's go ahead and put it on a number line to show that we understand what is really going on here. So let's go ahead and put these infinities on. And the first number we have is 8, and we're adding a positive 5, so we're moving to the right. So I'm going to put 8 over here to the left, and then we're moving to the right here, 5 units. So let's just put a few numbers here to the right of this so we can jump to our sum or difference here, whatever you want to call it. Technically, we rewrote it as an addition problem. And so we're starting out with the number 8 here. And so put a dot at 8. So we have 1, 2, 3, 4, and 5, right? So we're ending up at the number 13. So 8 plus 5 is equal to 13, which means that if you have 8 and you take away negative 5, that's equal to 13. All right, for number 3, we have negative 8 take away 5, a little bit more confusing to look at maybe than number 1, right? So we're going to go ahead and keep this, change the subtraction sign, and write the opposite of 5. If we go ahead and do that, we're going to keep the negative 8, we're going to change the minus to a plus sign, and we're going to change the 5 to its opposite, which is going to be negative 5. So really we have negative 8 plus negative 5, which is a little bit easier to wrap our heads around, I think. All right, so let's make a number line to show this. Go ahead and throw some arrows on there. Let's throw some infinities on there as well. And let's see, we're starting out with negative 8, but which direction are we moving? We're moving 5 units to the left. So we're starting with the negative 8, so let's move that to the right side. So we're going to be moving 5 units to the left. And so we'll put negative 9 here, negative 10, negative 11, negative 12, negative 13, and looks like we can fit maybe negative 14 on here as well. So we're starting with this negative 8. Let's go ahead and put a dot on negative 8, and we're moving 5 units to the left. So let's count here, 1, then 2, then 3, then 4, then 5. So looks like we end up at negative 13. So negative 8 plus negative 5 does equal negative 13. Hopefully that makes sense because negative 8 minus 5 is also negative 13. For number 4, we have negative 8 minus negative 5. To me, this looks the most confusing out of all these so far, but I think we can make it look a little less confusing if we keep, then change and flip, and rewrite this as an addition problem instead. So if we keep the negative 8, it's going to stay as negative 8, change the subtraction sign to addition, and then flip the negative 5 to make it a positive 5. So we have negative 8 plus 5. That's a little bit easier to understand. I think there's less symbols, right? So let's see what this looks like on a number line. And again, if you already feel comfortable with adding integers, then this hopefully makes this a little bit more clear too once it's addition. Okay, so the first number is -8, and we're going to add +5, so it's moving to the right. So let's go ahead and put the -8 to the left side of the number line, and this would be -7, -6, -5, -4. I'll just keep going until I run out of space here. -3. I could put on a -2. All right, so we're starting off with a -8. Go ahead and put a dot where we begin, and we're adding a +5, meaning we're moving to the right. So let's go over 1, 2, 3, 4, and 5. So -8 plus 5 is going to equal this -3, which is the same thing as -8 take away -5. That's still equal to -3. For number 5, 6, 7, and 8, we're going to be either writing always, sometimes, or never in terms of whether the answers to these statements would be a positive number or not. For number 5, it says a positive number subtracted from a positive number. This is going to be sometimes positive, okay? So we can go ahead and write sometimes positive in here. And let me give you 2 examples so you can see why sometimes it won't be positive, sometimes it will be positive. So if you have something with a greater absolute value minus something with a smaller absolute value, like 8 minus 3, keep in mind that's the same thing as 8 plus -3 if you keep change flip, and that would equal a +5, right? But on the other hand, what if you were subtracting 2 positive numbers like 3 minus 8? Those are both positive numbers. That would be the same thing as 3 plus -8 if you keep change and flip, and that would actually equal -5. So I just showed 2 examples where in one you would get a positive answer and one you would get a negative answer. So a positive minus a positive is sometimes positive. On a side note, a positive minus a positive doesn't have to be positive or negative. If they're the same number, then it could also equal 0, just so you know. For number 6, we have a negative number subtracted from a positive number. Okay, so this one's actually going to be always positive. So we're going to be subtracting a negative number from a positive number. So maybe I could show you a couple examples. So a negative number subtracted from a positive number. So let's say maybe a positive number, take away a negative number. So 10 minus maybe -7, right? So we just took away a negative number from a positive number. So if you were to rewrite this using addition, we keep the 10, change the subtraction to addition, and write the opposite of -7, that's going to be +7. That's going to equal 17, right? So whenever you take away a negative from a positive, you end up adding anyway. So maybe another example is if I did 8 take away -5, right? When you take away a negative, you're gonna really end up adding a positive. So if you keep, then change, then flip, you end up with an addition problem with 2 positive numbers. You'll get 13 here. All right, so whenever you take away a negative from a positive, you're always gonna get a positive number. For number 7, we have a positive number subtracted from a negative number. And this one is going to be never positive. Let's go ahead and write that down, never positive. Let me show you why. It might be a little bit tricky to kind of think through your head, but I think when they show an example, it'll make more sense. So a positive number is being subtracted from a negative number. So let's just choose a negative number, maybe something like -5, and we're going to take away a positive number. I'm going to say 4, okay? If we rewrite this as an addition problem, we keep the -5, change the minus to a plus, flip the 4 to a -4. Notice how we're going to have a negative number and we're going to add another negative number, and a negative plus a negative is just more negative. So that would be -9. If you took another negative number, I don't know, like something like -13, you take away another positive number like 10, right? Then we'll have -13, we keep that, change minus to plus, and then flip the 10 to its opposite, which is -10. Then -13 plus -10 is just more negative, it's -23, right? So whenever you take away a positive from a negative, it's just going to become more negative, so we can say that this would never be positive. For number 8, we have a negative number subtracted from a negative number. All right, this one's kind of interesting. So a negative, take away another negative. This one is going to be sometimes positive. Let's go ahead and write that down, sometimes positive. So this one really depends on the absolute values of the numbers, okay? So we're gonna do a negative number minus a negative number. So for example, let's do -8 take away -10. Let's look at this one, right? So if one of the numbers, let's see, has a, if we're subtracting a number that has a greater absolute value, let's see what happens. So if we keep the -8, change the minus to a plus, and the opposite of negative 10, if we flip it, is going to be positive 10. Notice how when we're adding these, the 10 has a greater absolute value. So this answer is just going to be 2, just because we're going to subtract 10 minus 8 to get 2. All right. Now, what if the first number has the greater absolute value? Like, what if it's negative 12, take away a negative 7, right? Notice how in this case, the first number has the greater absolute value. It's more negative, right? Then this is going to be keeping the negative 12, and then we're going to add or change the minus to a plus, and the opposite of negative 7 is positive 7. So negative 12 plus 7 is really just 12 minus 7, which is 5, but this answer is going to be a negative 5 instead. So basically here, notice if we are subtracting a number with the greater absolute value, like negative 10 has a greater absolute value than negative 8, then we're going to end up with a positive number because we're going to end up flipping that number that's further from 0, right? But in this case over here, this negative 7 has a smaller absolute value from negative 12. So even when we flip this negative 7, it's not going to be enough to pull it into the positive, so we're going to get a negative answer, right? So we're going to get sometimes positive. And just like in number 5, we don't have to necessarily get a positive or negative answer. We could also get the number 0, right? So if you had something like negative 8 take away another negative 8, that ends up just being, if you keep and then change and then flip, you notice that you're just adding opposites together. That would equal 0. All right, let's try some problems where we're just going to go ahead and subtract and see how we do. To subtract though, let's make sure we are rewriting each of these differences, which are differences are just subtraction problems. We'll rewrite them as a sum first. So we'll keep, change, and flip. That's basically what that is saying. Keep, change, flip. All right, for number 9, we have 20 take away 13. We're going to keep, then change, then flip. I know this one's pretty straightforward to do, but let's just practice doing it anyway. So we have 20 and we're going to add a negative 13, right? Now they're opposite signs, so make sure you subtract their absolute values. 20 minus 13 is going to be 7. And then we keep the positive just because 20 has a greater absolute value. For number 10, we're going to also keep, change, flip. For all these, we're going to keep, change, flip. So we're going to keep the 13 here, 13, and then change minus to plus, and the opposite of 20 is going to be negative 20. Now these have different signs again, so let's subtract 20 minus 13, that's going to be 7, but this case it's going to be negative 7 because this negative 20 has the greater absolute value. For 11, we have this 7 take away a negative 4, so we'll keep, change, and flip. Keep the 7, change the minus to a plus, and then flip the negative 4 to positive 4. This is really just 7 plus 4, so it's 11. We don't have to worry about absolute values, just add them. For number 12, we have negative 4 take away 9. So if we keep, change, flip, we'll keep the negative 4, change the minus to a plus, and we're going to flip the 9 to a negative 9. That's its opposite. Now we're adding two negatives together, which is kind of nice because you're just going to get more negative. For number 13, we have 15 take away negative 8. So we'll keep, change, flip. The 15 is just going to stay the same, but I'm going to change the minus to a plus, and the 8 is going to become positive. So this is really just 15 plus 8, which is 23. Okay. For number 14, we have negative 9 take away 5. So if we rewrite this as an addition problem, it's going to be negative 9 plus the opposite of 5, which is negative 5. So we really are adding two negatives together. So negative plus a negative is more negative. So 9 plus 5 is 14, and it's going to stay negative. Okay, so just to recap here, once you rewrite them as addition problems, then if they're different signs, you subtract and take the absolute value of the greater number. Then over here, notice how we have different signs as well, but you take the absolute values and you look at the one which is further from 0. So this one's negative. But in number 11, these are both positive, so just add. In 12, they're both negative, so just add. In number 13, they're both positives, just add. And in 14, they're both negatives, just add. Okay, so the only time you subtract is when they have different signs. For number 15, let's go ahead and do 14 take away this 23. If we rewrite it as addition, it's going to be 14 plus negative 23. Notice how they have different signs now. So 23 minus 14 is going to be 7. And we're going to take the sign of the negative just because this negative 23 has a greater absolute value. For number 16, we have negative 6 minus 15. So we'll keep, change, flip, and rewrite this as an addition problem. So negative 6 plus negative 15. Now we're adding two negatives, so just add 6 plus 15, that's 21. And it's going to be negative since a negative plus a negative is just more negative. For For 17, we have 13 take away a negative 19. So let's rewrite this as an addition problem. Keep the 13, change minus to a plus, and flipping the negative 19 gets you a positive 19. So really this is just 13 plus 19, and that is going to be 32. That's positive. Okay. For 18, we have 17 take away 24. So if we keep the 17, change the minus to a plus, and then flip the 24 to a negative 24, notice how one is positive, one is negative. So we're going to subtract 24 minus 17, that's going to be 7. And the answer is going to be negative here, just because the negative 24 had a greater absolute value. For 19, we have negative 15 take away a negative 33. If we rewrite this as an addition problem, that's going to be negative 15 plus, and that's going to be, if we flip negative 33, that's just positive 33. And these have opposite signs, so we're going to subtract. 33 minus 15 is going to be 18. And I'm going to keep it as a positive number just because 33 had a greater absolute value. For number 20, we have negative 25 minus 13. So if we rewrite this as an addition problem, it's going to be keep the negative 25, change minus to plus, and the opposite of 13 is going to be negative 13. So if we're adding two negatives, that's just going to be more negative. That's going to end up being negative 38. Alrighty, now let's go ahead and try subtracting some different types of values. So we're going to still be subtracting. We're going to rewrite each of these differences as sums again. So we're going to do the keep, change, flip, and turn all subtraction problems into addition problems. But in this case, we're going to be dealing with rational numbers, not just integers. So we're going to have some fractions and decimals. For 21, we have 4.7 take away 9.3. We're going to keep, then change, then flip. If we do that, this is going to be the same thing as 4.7 plus a negative 9.3. Okay, so notice here that they have different signs. This one's positive, this one's negative. If that's the case, we're going to go ahead and subtract their absolute values. So we're going to take 9.3 and we're going to subtract 4.7. Okay, so we're going to have to borrow here. This is going to become an 8. 3 is going to become 13. 13 minus 7 is 6. And then 8 minus 4 is 4. So we're going to end up with 4.6. So we're going to go ahead and write here that this is going to be 4.6. But is it positive or is it negative? Well, this one is positive, this one is negative, but this negative 9.3 has a greater absolute value. So this must be a negative 4.6. Okay. For number 22, we have 2.8, and we're taking away this negative 5.7. So we're going to keep, change, flip. If we do that, we're going to have 2.8 plus a 5.7. Okay. And so these are both positive numbers, so that's nice. We don't have to do any subtracting. We're just going to add their absolute values. Positive plus a positive is always positive, so it's just going to become more positive. 8 plus 7 is 15, carry the 1. Then 1 plus 2 plus 5 is 8. So I'm getting 8.5 here. So if we go ahead and write this answer, we're going to get 8.5. For 23, let's go ahead and see we have negative 2.9. We're going to keep that, change this minus sign to a plus, and then flip this 5.4 to a negative 5.4. So negative 2.9 plus negative 5.4. Okay, so this one's actually kind of nice. They're both negative numbers. So a negative plus a negative is just more negative. So we really just have to add their absolute value. So 2.9 plus 5.4. All right, so 9 plus 4 is going to be 13, carry the 1. Then 1 plus 2 is 3, plus 5 is going to be 8. So if we go ahead and add these, we're getting 8.3, but it's a negative 8.3 just because we're adding a negative plus a negative together. All right, for 24, we have negative 9.6. We're going to keep that. We're going to change minus to a plus, and we're going to flip this 4.9. So rewriting this as an addition problem, we have negative 9.6 plus a 4.9. Okay. Now, because we have a negative and a positive, we're going to have to subtract their absolute values, and we know the answer should be negative because negative 9.6 has a greater absolute value. Okay, so let's take this 9.6 and subtract the 4.9. Okay, so we have to borrow from this 9 to make it an 8. This is going to get the 10 from it. It's going to become 16. 16 minus 9 is 7, and then 8 minus 4 is going to be 4. So we're going to end up with 4.7, but it's a negative 4.7. Just because the negative 9.6 had a greater absolute value. For number 25 here, we are dealing with some fractions, and they do have common denominators here, which is really nice. Even though we could just subtract here, we really want to just practice turning all subtraction problems into addition problems. So if we keep this, we're going to have 5 over 9, and then we're going to add, and then this is going to be a negative 2 over 9. Okay, so that's what that same thing is going to be as an addition problem. Now keep in mind that when we are adding fractions, we need common denominators, which we do have here. So let's go ahead and keep 9 on the bottom, and make sure we know that this minus sign is going to go to the top, right? So this is going to be 5, and then we're going to be adding this negative 2. All right, always give that minus sign to the numerator. Now, if we're adding 5 plus negative 2, they have different signs. So we'll do 5 minus 2, and that's going to be 3. So if we get 3, that's going to be positive because 5 had a greater absolute value, so we have 3/9. And then we can notice here that we can actually simplify by their GCF. So their GCF is 3 here. So if we divide top and bottom by 3, we're going to get a final answer of 1/3. On to number 26. It looks like we're subtracting some fractions again, and we have common denominators, which is really nice. If we keep, then change, then flip, then we'll keep this 5 over 12. We'll change the subtraction to addition, and if we flip the negative 3 over 12, that's going to be a positive 3 over 12. Okay, so we do have common denominators, so that's really nice. Like we said, this is going to stay as 12 on the bottom, and we're going to add 5 plus 3 on top, which are just positive integers. 5 plus 3 is going to be 8, so we'll have 8 over 12. Now think about what their GCF would be. If you need to write out some work on the side, feel free to do so. 4 happens to be their GCF. If you divide both by 4, then we're going to get 2/3 for our final answer. Here's 27. For 27, looks like we have common denominators, which is again really, really nice, all things considered. And so if we keep the negative 3 over 16, just keep that and leave it alone, negative 3 over 16, change the minus to a plus, and then if we flip this 5 over 16, it'll be negative 5 over 16. Okay, so let's go ahead and give the minus signs to the numerators. So if we go ahead and do so, 16 is going to stay on bottom. The negative goes up to the 3, that's negative 3, and the negative goes to the 5, so it's going to be a negative 5. Okay, now we're adding two negatives together here. A negative plus a negative, remember, is just more negative. So negative 3 plus negative 5 is negative 8, and that's going to be over 16. Okay, now remember, if we have a negative in our answer, we can just move it to the middle of the fraction bar. That's going to be negative 8 over 16. And then we got to see if these are relatively prime, but I think they have a GCF of 8. Right, 8 goes into both of those. So we divide them both by 8, we're going to get negative 1/2 for our final answer. For number 28, we are subtracting some fractions again. We have common denominators, which makes it a little bit nicer. And so we're going to have this negative 7 over 18. We're going to keep that. And then we're going to change this to addition sign and then flip the negative 1 over 18 to a positive 1 over 18. So let's go ahead and move that negative sign up to join the 7. So we have 18 on bottom. We have a negative 7 plus 1. All right. Now adding this negative 7 plus 1, they have different signs, so we're going to subtract them. 7 minus 1 is 6, and it's going to be a negative 6 just because the negative 7 had a greater absolute value, right? So we have negative 6 over 18, and we can go ahead and move that minus sign to the middle of the fraction bar, okay? And then let's see if we can simplify this. Looks like 6 would be their GCF. So if we divide by their GCF, we should get relatively prime numbers on top and bottom. So that should be negative 1/3. Moving on to 29, this is the first one that's a little bit more annoying because we don't have common denominators. So we have to find out when 10 and 4 meet for the first time. So they have a GCF of 2, that's going to be 5 and 2. Then if we want to figure out when the first time they meet, looks like it's going to be 20, right? So the LCD here is going to be 20. So it's an extra layer or an extra step we have to consider here. We can either keep change flip now or change them to having the same common denominator. Whichever one you want to do first is perfectly fine. Maybe I will keep change flip first just to keep things consistent, and then I'll deal with the denominators in just a moment. So keeping this first one, that's going to be negative 3 over 10, and then changing minus to a plus, and then instead of 3/4, it's going to be a negative 3/4, right, if we flip it. Okay, now to get the common denominator of 20, we're going to have to multiply this one by 2 and this one by 2. And for this 4, let's multiply this one by 5 and multiply this 3 by 5. So these new fractions here would be negative 6 over 20 plus, and that's going to be negative 3 times 5 is 15 over 20. Okay, now let's go ahead and give the negative signs to the numerators. I'm going to go ahead and move this to the right side here because I'm going to be running out of space soon. So that 20 is going to stay on bottom. Remember, this negative is going to join the 6, so that's going to be negative 6 plus, and then let's take this negative and let it join the numerator again, so that's going to be a negative 15. Okay, now we're adding two negatives, which is kind of nice because we just get more negatives. So 6 plus 15 is 21. So we're going to end up here with a negative 21 over 20. And we can move that negative sign to the middle. So it's negative 21 over 20. And you can leave it like that, or you can rewrite this as negative 1 and 1/20 as a mixed number. For number 30, go ahead and notice that we're actually adding fractions here, right? And so it's different from all the other ones. And I just want to make sure you're paying attention and we understand that you don't always have to keep, change, flip. It's just when we have subtraction problems. But when we do have addition problems, in the instance where we're adding a negative like we are here, keeping and changing and flipping can still help us a little bit, right? So just showing you some different types of problems here. If we keep, change, and flip, it actually might make this problem look a little bit simpler. So we have 9 over 14, and we change the plus sign to a minus sign, and then flip the negative 2 over 21, that would be a positive 2 over 21. So you can keep, change, and flip addition problems as well, and it ends up having one less symbol here, which might be a little bit more convenient, depending on your preference, right? So we still need common denominators, so 14 and 21, let's see, their GCF is 7, 7 times 2, 7 times 3, and then let's see here, 7, 2, and 3, so the LCD here is going to be 42. That's going to be the first time they meet. So it's going to be 14 times 3 here. We'll do times 3 up here as well. 21 times 2 and 2 times 2. Okay, so in this instance, what we're going to do is we're going to have 9 times 3 is 27. And then we're going to, on the bottom, let's see, we have 42, right? That's the common denominator. And then 2 times 2 is 4 on top. So 27 minus 4 on top is going to be 23. So we're going to get 23 over 42. Okay, so again, if you wanted to not keep, change, flip in this problem, that's also fine. But I think it's important to know that you actually can keep, change, flip for addition problems, and it sometimes can be helpful, sometimes maybe not. Depends on your preference and it depends on the problem. For number 31, we have another problem here. Now, in this case, notice how we're adding again. So we don't need to keep, change, flip, and we're adding two negatives. So I don't think I really want to, just because when we're adding two negatives, it's not maybe as useful because you can just add these numbers or add their absolute values, right? So again, it's a case-by-case scenario. Just want to make sure we're thinking pretty critically about why and when we are doing things, okay? So when do 10 and 8 meet for the first time? 10 and 8, let's see, they have a GCF of 2, that's going to be a 5 and a 4. And so 2 times 5 times 4, that's going to be 40. So the first time these numbers meet are going to be at 40. Okay, so if we go ahead and just rewrite this problem, let's make sure this is 10 times 4, and then 3 times 4 to get the 40 on bottom, and then 8 times 5, and then 5 times 5 on top. So if we rewrite these fractions here, the first one is going to be 3 times 4 is 12 on top, and that's going to be over 40 for 10 times 4, and then plus this negative fraction, 5 times 5 is going to be 25 on top, and then 8 times 5 is going to be 40 on bottom. Okay, now if we're going to go ahead and move these negative signs to the top, that's going to be negative 12 and negative 25. Then on the bottom we have 40, but on top we have negative 12 plus negative 25. Okay, now we're just adding two negatives here. So a negative plus a negative is just more negative. And so that's going to end up being here, 12 plus 25 is 37. So we're going to get negative 37 over 40. And then we can go ahead and move the negative sign to the middle. So it's going to be negative 37 40ths as the fraction. And 37 and 40 are relatively prime, so we can't simplify it anymore. Okay, for this last problem, we have this negative 5/18 plus the 7/12. Now it's already addition, I don't think if we kept, changed, and flipped that this would make it any easier. We would end up subtracting a negative, which would be a little bit more difficult, I think. So let's just go ahead and keep these the way they are. And because we have a negative fraction and a positive fraction, let's just make sure we subtract their absolute values. Okay, so let's see when 18 and 12 meet for the first time. Their GCF to me is 6. I think that's going to be a 3 and a 2, so those are relatively prime. So looks like 36 would be the first time they meet if you multiply these together. Okay, that would be the first time 18 and 12 meet. So 18 times 2 gets you 36, 5 times 2 is 36, 12 times 3 is 36, and 7 times 3 is 36. So for this first fraction, 5 times 2 is 10 on top, and then 18 times 2 is 36 on bottom. And then we have 7 times 3 is 21 on top, and then 12 times 3 is 36 on bottom. Now this is a negative 10. Let's give that negative to the numerator. So that's going to be a negative 10 plus this 21 on top, and that's going to be on top of 36. That's in the denominator, that common denominator. And we're adding a negative plus a positive, so make sure we subtract their absolute values. 21 minus 10 is going to be 11, and since 21 is a greater absolute value, it's going to be positive 11. So we can write our final answer here is going to be a positive 11 over 36. Okay, so there you have 32 different practice problems on mainly subtracting fractions as well as decimals as well as integers, and making sure that we know when to keep, change, flip, or turn subtraction problems into addition problems, but also knowing that we can change addition problems into subtraction problems and go the other way as well. Now I'm just going to go ahead and box all my final answers here for each problem just to make these a little bit more clear. Alrighty, so we have this negative 37 over 40, got this one, this one. What else do we got here? We had this negative 1 and 1/20th over here, but technically this improper fraction is also good. This would be negative 8.3. We had negative 1/3 here. We had positive 8.5. We had a negative 1/2. That was our simplified answer, negative 4.6. Let's see what else we had here. We have negative 14, 23, negative 13, 11, negative 7 and 7, negative 7, negative 21, 32, negative 7, 18, and negative 38. So hopefully that makes it a little bit more clear where all the answers are. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work. I'll see you in the next one.